Hey everyone, and welcome! Today we are going to tackle something that, I know, looks way harder than it actually is, dividing rational expressions. But stick with me, I promise by the end of this you are going to feel totally confident and in control of these things.
Okay, let's just dive right in. Take a look at this. I mean, it looks like a total mess, right? You've got polynomials, fractions on top of fractions. It's a lot. But what if I told you the secret to solving this whole thing is a super simple trick you probably learned like way back in elementary school?
No, I'm serious. All that complicated, tangled up math we just looked at, it all comes down to one simple rule that you already know. Trust me on this. You've totally got this.
All right, so here's our game plan for today. We're going to start with what I call the golden rule, the thing that makes all of this possible. Then I'll lay out a four-step process that I'm telling you works every single time. We'll walk through a few examples, point out the common mistakes so you can avoid them, and then we'll talk about why this actually matters beyond your math class. Sound good? Let's do it.
Okay, so here it is. This is the single most important thing you need to remember. It's a little mantra. Keep, change, flip. Seriously, this little phrase, it's the key to unlocking everything.
So, what does keep, change, flip actually mean in math terms? Well, it's pretty simple actually. It just means that to divide by a fraction, all you have to do is multiply by its reciprocal. So, you keep the first fraction exactly as it is, you change the division sign to a multiplication sign, and you flip the second fraction upside down. That's it. That is the entire trick.
Okay, now that we have our golden rule down, let's build out our four-step blueprint for success. This is the process that's going to guide us to the right answer every single time. So here's the plan. Step 1, and you always do this first, is apply, keep, change, flip. Just turn that division problem into a multiplication problem. Easy. Step 2, you have to factor everything you can. And I mean everything. Every single numerator and every single denominator. Step 3 is the really fun part. You get to cancel out any common factors, anything that matches on the top and the bottom. And finally, step 4, you just multiply whatever's left straight across. That's our roadmap.
All right, enough talk. Let's actually see this process in action. We're going to put it to the test and start with a pretty straightforward example just to get warmed up.
Okay, example 1. We've got x over 5 divided by x squared over 10. See? Nice and simple. We don't have to worry about any crazy factoring just yet.
So, what's our first move? Yep, you already know it. Keep, change, flip. We keep the first fraction, change division to multiplication, and flip that second one. So our problem becomes x over 5 times 10 over x squared. See, it already looks so much easier to deal with.
Okay, now we just simplify. Let's look at the numbers first. We have a 10 on top and a 5 on the bottom. Well, 10 divided by 5 is 2, so that simplifies to 2 over 1. Now for the variables. We've got an x on top and an x squared on the bottom. So that single x on top cancels out one of the x's down below, leaving just one x in the denominator. So what are we left with? A 2 on top and an x on the bottom. Our final answer is 2 over x. See? Not so bad at all.
All right, you ready to level up? This next one is going to require us to use those factoring skills we've been working on. But guess what? We start the exact same way. Keep, change, flip. That never changes. So we now have x squared minus 4 over x plus 1, and we're multiplying that by 3 over x minus 2. Okay, now for step 2, factoring. Take a look at that numerator, x squared minus 4. Does that look familiar? It should. It's a classic difference of squares. It factors out into x plus 2 times x minus 2. So now if you picture it, we've got an x minus 2 on the top and, look at that, an x minus 2 on the bottom. What do? We cancel them out. So what's left over? We've got the 3 and the x plus 2 on top and the x plus 1 on the bottom, and that's our final answer.
All right, deep breath, it is time. Remember that really intimidating problem from the very beginning, the one that looked impossible? Let's go back to it, because now we have all the tools we need to completely dominate it.
And step 1 is our old friend, keep, change, flip. As always, we immediately rewrite the problem as one big multiplication. And you know what? Just doing that makes it look a whole lot less scary. Okay, now for the main event. Let's factor everything. That trinomial on the top left, that becomes x plus 1 times x plus 2. And that difference of squares on the bottom left, that's x plus 1 times x minus 1. Okay, look at that. Now we can see all the little building blocks we're actually working with.
And here it comes, the most satisfying part of the whole process. Let's start canceling stuff out. We've got an x plus 2 on top and on the bottom. Gone. We've got an x minus 1 on top and on the bottom. Gone. And what about the x plus 1s? Yep, one on top, one on bottom, they're gone too. Everything cancels out. So that big, scary, intimidating problem from the beginning simplifies all the way down to the number 1. How cool is that?
Okay, this process is super powerful, but I gotta warn you, there are a couple of common traps that students fall into all the time. So let's talk about them so you can steer clear.
All right, there are two major things to watch out for. The biggest one, by far, is flipping the wrong fraction. It's so easy to do. Remember, you only flip the second fraction, the one that comes after the division sign. The other pitfall is a little more sneaky. It's about domain restrictions. When you flip that second fraction, you create a brand new denominator, right? Well, you have to check that new denominator for values that would make it 0. For instance, say your new denominator becomes x minus 5. Well, that means x can't be 5 in your answer, because that would make you divide by 0, which is a big no-no in math.
So at this point, you might be thinking, okay, that's cool, but why do I actually need to know this stuff? And that's a fair question. Turns out, this isn't just some random exercise for your math textbook. It has some really practical applications. For example, if you ever go into chemistry, the formulas for things like reaction rates can get super complicated. They look a lot like the problems we just did, and you use this exact skill to simplify them. But maybe more importantly for you right now is that what we've done today is the absolute core skill you need for your next topic, complex fractions. And those are just what they sound like, fractions inside of other fractions. You really have to have this down to be successful with those. And this is why I love this quote here. It really puts it all into perspective. It says dividing rational expressions is almost identical to multiplying them, with one extra first step. And that's so true. If you can already multiply these things, you're like 90% of the way there. The only new thing we added today was that one little step at the beginning, keep, change, flip.
So there you have it. We took a problem that looked completely impossible, applied one simple rule and a clear 4-step process, and we broke it all down to a super simple answer. You now have all the tools you need to tackle any of these division problems. So the only question left is, what challenge are you going to conquer next?